All right, class, this tutorial here is going to walk you through how to use an Isovist to start mapping the data onto given floor plates. So an Isovist is a calculation, a geometric calculation of all of the objects that you can see from a given point in space or location. We're going to continue working in a similar fashion to what we had been using the lunchbox quad component to map out across a facade, or excuse me, across a floor plate, a relationship to certain objects. In this instance, we're going to map out the relationship to the objects that can be seen from that part of the floor plate. So what I've done here is taken just that conceptual mass model that we were playing with earlier in the week with a series of mass floors at about 10 or 12 stories. You can use your same model. And what I've done is I've put in a series of conceptual masses that are just boxes. The important part here is that you make them so that there are varying heights and that they don't, that they're not all the same, but that they aren't all taller than your the conceptual mass you're building that we're going to actually analyze. So in Dynamo, I've got a new component opened up here, and in contrast with the way we've looked at these bringing elements into Dynamo in the past, or similar to what some of you have been doing, we're going to use the category component. Categories brings in a drop-down list that allows you to select the type of object that you want to bring in from inside of Revit. I'm just hitting the letter M here to skip down to mass, and I'm going to bring in all the conceptual masses, and then I'm going to ask it to get all elements of this category. So I'm also under category going to bring in this all elements of category and plug in the name. So this category's button is simply just the name of particular objects. This is actually grabbing them from Revit, and then we need to convert those elements into solids. The machine is running very slow tonight. And you'll see as soon as I get them converted into solids that they all come in. I'm going to hit the zoom out to see all these objects, and just rotate around so I can see my tower in context. We'll jump back into the components. So we're going to want to copy this first two sets, these first two components here, because we also need to bring in all the mass floors. So I'm going to change this first one from mass to mass floor. And now this component is holding all of the mass floors that are inside of there. And then again, as I did here with the element solids, I can also do with the element to faces. Plug that component in. I'm not seeing those because they're inside of this this piece here. So what we need to do is do a remove element, or excuse me, a remove item by index. So we're just using an index component the way that we've used it to go get an object. In this case, we're going to use it to actually get rid of an object in the list. In this case, this mass at the center. And I just need, I'm going to put in a slider because I'm not sure what exactly which object this is going to be. So I'll try 0, and that's it. So you can see that now when I select this list remove item at index, it's not highlighting my center object. And so if I turn the preview off, now what I've got are just my mass floors on my tower design, and then the rest of the objects floating around. So I told you that Isovist work based on a given point. So let's put in a point. that we can just use to create an example here. Eventually we're going to use points on these surfaces. This point I'm going to plug into the Isovist component, which is Isobist. Create Isovist. And you can see this needs a whole series of different objects and different inputs coming into it. Please be really careful about how you use this, because you can overwhelm the computer really quickly. So just to create this example, I'm going to plug my point in here as the origin, and then I'm going to make a series of sliders. I'm just going to copy this one, and I need 4 sliders for this. You can mouse over and sort of here. You can infer what's going on here, but you can also mouse over to see what components what these things are each looking for. So the radius here I'll plug in is about, I'm not sure how big my components are, so I'll hit, or how big my objects were, I'll hit 300 for that. The start angle will be 0, and we want to go all the way around, so I'm going to put in 360 for the end angle. And the ray count, I'm going to start off very small. I'd say 10. Please be careful with that. And so then this last boundary component is the geometry, which is basically these solid objects around our model. So I'm going to plug those in there. And you'll see that immediately I get on every 36-degree increment, because I have 10 rays getting shot out across 360 degrees, that I'm getting only the lines which are actually intersecting this object or any of these objects. So if I increase this slider up to say 60, that would be on 6-degree increments, and now you start to see how this is really working. And if I rotate the geometry and kind of let you see here, you can see it's only showing me the lines that are shooting out from my original point that are hitting any of these objects below. So now what I'm going to do is actually turn these components back down, just so that I don't overwhelm the system. I'm going to set it back down to 10. And now, instead of using a single point as my origin, I want to actually create quads on all of these mass floors. The way that I have been using the lunchbox quad component in order to start looking at how different parts of the floor plate, what different parts of the floor plate can see. So I'll put in quad. There's my search bar, and there's my lunchbox panel quad. And I'm going to plug in all of the surfaces here. And again, I want to be careful about how much division I give it. I'm going to copy a slider again. I'm going to start this off at just 4 panels in the U direction and 4 in the V. And I can turn this up later, but for now that's going to be more than enough for the computer to handle. And then what I want to do, and this is a little different than what we've been doing, this creates a series of points at the corners of the panels. For this one, I want to actually look at the center of each of the panels. So to create a center point, I'm going to put in a surface point at parameter component. It's this one here. And you can see what this one looks for is also a U and a V. But what it's actually trying to do is it's using between 0 and 1 to assume an ISO curve across that surface. So across any surface, if I put in a 0.5 to the U and a 0.5 to the V, it's going to give me the midpoint at that surface. So I'm going to plug my panel quads into that component, and then put in a new slider that's set to, or you can put in a number that's set to 0.5. So 0.5 again would be the midpoint, or the mid ISO curve at a given point here. And you can see I'm getting 192 points coming out of my component. you can also see when I hit this that now I've got lists within lists, and that this is starting to become, it's related to each of the different floor plates. So each floor plate has a series of points that are associated with it. I need to strip that out in order to get this isocurve to function. So I'm going to flatten these points. Again, the flattened components just strip out information. And hit that pin to make my list go away. And now what I'm going to do is swap in these points at each of the centers from each of the floor plates, the center of each of the quads that I've created, into this Isovist, and hopefully the computer won't crash. Okay, so it didn't crash because it's inferring that the shortest list of objects is the most important, and so right now the boundaries are set to just, it would be the shortest list of objects that are in there, and so I'm gonna hit right click on this and change the lacing over to longest, and now the computer should think quite a bit. There you go. So now what we're getting are all of the Isovist lines, all of these rays that are shooting out. Now flip into the geometry mode here so you can see in 3D what's going on. From each quadrant, it's showing me only the lines that are actually intersecting with the buildings that are surrounding our site. So I can get rid of this original point that we made, and I'm going to go ahead and turn this up to 30 so that at least we're looking at, and be careful here, if your computer was struggling at 10, it's definitely going to struggle at 30 because it's going to be 30 times 192 different panels, which is what I've got. And you can see this is thinking about it a little bit. It flashes to Revit because it's rendering all of these things in Revit in real time as we're doing it here in Dynamo. And so now what I want to do is take a look at the information that this Isovist is putting out. So I'm going to put a watch component in here. And if I plug in the minimum length, you can see what I get are a list of all the points and the minimum ray length that they have from their given location. And then I can put in a max, and I can also put in an average. So I could go ahead and plug these in, but they're not that relevant in terms of what we're actually seeing. What might be more relevant is when you have a view from a given location. And because these buildings are occluding the view, we want to look for parts of the building that have more views than others do. And so the only way to calculate that would be to look at the number of rays. So I'm going to plug the rays into this watch list. And you can see that it's a series of, it's 3,094 rays. I think I'm going to turn this back down to 10 just while we do this, so it's not thinking so hard. So you can see when I turn it from 10 and then hit return, it's going down to just 1,000 rays right now. And what you can see is from any given location, I'm getting this list of 0 to 7, the number of lines that it's actually hitting. And what I could presume is that the number of lines is actually a bad thing. If I'm hitting a bunch of objects, then that means it's not working, that the view from that location is not very good. So what I want to do is actually get a count for the number of objects for each of my points, and I'm going to use that to create the coloring on the plane on each of the panels. So I'm going to put in a count component, and if I put this in here, I'm just getting 192. And the reason that that's happening is because it's counting the number of lists that are actually in the object. Oh, Bogart wants to go outside. Okay, I'm back. Hopefully he'll be comfortable until we are done here. So again, I was referencing this count is going to come up as 192. And depending upon how your model is organized, you're going to have to screw around with this to get the data organized in such a way that you're able to count how many objects are actually emanating or hitting a building from each of the centroids of a panel. So what I'm going to do is use a flatten component, but this time I'm going to activate this little arrow here, which opens up a thing where I can use the levels of the structure to actually see what's going on. So I'm going to undo that and just put a second watch component on here so you can see exactly what's happening. So what we've got right now is a list of lists that have the number of lines, the actual lines. It's containing all the lines that come from a given point. If I select one of these, one of those somewhere down in there is blue. When I use a typical flatten, I'm going to get this giant list of 1082 lines without any structure. That's not what I want either. So if I turn this over so that it uses the levels, you can see that it removes one level of the list from the structure. And now when I put the count component onto this list, it's still giving me 192. Let's take a look at that. Okay, so the simplest way to do this is not to actually use the flatten, which I've used in the example when I was trying to put this together, but instead to use the levels structure here inside of the count component. So by default, when I just plug the rays right into the count, it's going to look at all the rays for all the different quads on every floor. And so by default, I'm getting 192, which is the number of planes that I have. If I were to flatten the list, I was getting 1,000 and some. So if I use levels and say go to level 1, you're going to see that it does exactly that. It flattens and it counts to see that it's got 1,082 single lists with a single line in each of them. But if I go to the second level of the layer structure, now you can see that I get a list of I get a count of how many lines are emanating from each point and hitting a building. And this is exactly what I want. This is what I'm going to base my color data on when I go to assign it to each of the original quad panels. And so now you can just wrap this up by doing the same sets of components that we've been using. A remap component, remap the range. So this is going to remap those numbers that are now going from 0 to say 8 or 10. So I'm going to plug those in, and then I'm going to also go ahead and take the lunchbox domain component. Lunchbox get domain. And again, this domain by default is just 0 to 1. But we need this in order to apply it to the color gradient. And color range. And so the domain goes into the indices, the list goes into the value. And now the last part of this is to display the color, which is further down here. I'm just going to type in display. And my color goes into my color. And to zoom out, I'm going to get my quads. I'm going to take those original quad panels and put them into the geometry. Now, a lot of you were getting this on Monday, where you're getting grays and the colors are not kind of matching up the way that you would expect, especially with these grays over the top. You have to make sure you understand that each time you put another component in, especially once you get after this panel quad, you're making copies of that geometry, and all that geometry is sitting over the top here, and it includes the view. So I need to go through and turn the preview off on all these components, and once I get it cleaned up, I need to turn maybe these original element faces off. And then my color goes into my color, and to zoom out, I'm going to get my quads. I'm going to take those original quad panels and put them into a geometry. Now, a lot of you were getting this on Monday, where you're getting grays and the colors are not kind of matching up the way that you would expect, especially with these grays over the top. You have to make sure you understand that each time you put another component in, especially once you get after this panel quad, you're making copies of that geometry, and all that geometry is sitting over the top here, and it includes the view. So I need to go through and turn the preview off on all these components, and once I get it cleaned up, I should be able to I should get the colors that are actually associated with my color range. And again, this should look a little bit different, right? Because on different floors, I'm getting the different number of components that are going through it. But this also is incorrect. This is incorrect because the mapping of the list is not quite aligned. I can tell because it's got a solid color for these whole sets of things that are going up. So I would guess that we need to flatten something. The way to look for this is to look at the kind of list, the kind of information that you're plugging into each one. So here, it's telling me I've got 960 quads, but I've only got 192 colors. That's because it's giving me panels and points there. So that's correct, there's 192 panels, but the key part here is that there's lists of lists of lists of lists coming all the way down, but the color gradient only has a single list. And so that's your clue that things aren't quite right. So what I need to do is take one more flattened component. I'm just going to copy paste this one, and you can see it's already hidden. That's going to ensure that I don't overwrite the geometry, and then I'm going to plug it in. And now I'm getting what I would expect, which is that this corner, which is away from all of the other towers, is the most intense or the highest value where you're going to have the most view. The other way to make this work a lot better is to come back to the slider and turn up the number of rays that you're getting from each component. You may want to actually hide the rays. At some point they're going to kind of overwhelm the color. But now that I turn up the rays, I should get more of an accurate gradation of the different colors from different parts of the building. Hopefully. Maybe. I'll pause and come right back. And here you go, as promised, a much tighter gradient. I've turned the preview off on the actual Isovist. I've got 30 of them here. The other things, that of course you can do to get more accuracy would be to turn up, say, the divisions on the surface. Now, please be really careful here. So, for instance, when I go from 4 to 6, it's going to go from having 16 quads on each surface to having 36. So this is probably going to think quite a bit, and I'll pause again and come back to show you. And here that is now with more control. And again, you can see here at the corners where I'm going to see a lot more than I'm getting a lot more detail. And this is an inversion of the gradient the way you would expect it, right? So down here are lower values, meaning there were lower intersections with objects, meaning there's more of a view from those given spots. And then down here, of course, in the greens, there's a less of a view, and the further you get into the greens, the worse the views get at those given locations. Okay, good luck.